Welcome back, everyone. Today we're going to talk about another great topic in AP Calculus, and that would be implicit differentiation. Okay, so we're going to start off by talking about a little vocabulary. So the equations that you're used to are called explicit equations, where one variable is expressed explicitly in terms of the other. For example, if I had y is equal to 2x squared plus 3x minus 15. In this example, we have our variable y expressed in terms of x. Okay, an implicit equation is where both x and y are on the same side of the equal sign. So for example, if I have x squared plus 3y squared is equal to 5. Okay, now both x and y are on the same side of the equal sign. Okay, so we're going to start off with some pretty simple examples just to kind of get us started and help us understand the notation and how it is we're supposed to write this. So I first of all want to make sure that we are reading this correctly, right? So this is the derivative with respect to x. So the variable in the denominator is the variable that we are taking the derivative with respect to. So this first one is no different than what we've been doing, right? The derivative with respect to x of x squared is simply 2x. And the way that we knew that that was exactly the same as we're used to is because the variable in the denominator matches the variable that we're taking the derivative of. And so when that happens, we just follow along with our normal rules. Okay? So how is it different when we look at number 2? We're here, x and y, these do not match. So we're taking the derivative with respect to x of y to the third. So here's how we're going to do that. First of all, we go ahead and use our derivative rules on the y cubed as you would think we would. So that would be 3y squared. And now we actually have to differentiate the y term using the chain rule. So we first take the derivative, and then if we want to think of that y as the inside, we now have to take the derivative of y with respect to x. So we write dy dx. So this whole thing is our answer, 3y squared dy dx. All right, let's try number 3. So again, it's derivative with respect to x of x plus 3y. So we're taking the derivative of two different pieces. First, the derivative with respect to x of x, which is just simply 1. Then the derivative with respect to x of 3y. So plus, again, take the derivative of the 3y term, which would just be 3, but now we have to take the derivative of the variable y with respect to x. So dy dx. And so that's our answer for that one. Okay, this next one we're taking the derivative with respect to x of xy squared. So when you're looking at what you're taking the derivative of, you have to keep in mind of everything that we've been talking about up to this point. And what is it that we're taking the derivative of? Well, it's xy squared. And what is the operation that's going on? That is multiplication. So in fact, we do need to use the product rule here as we evaluate this derivative. Okay, so when we do it, don't forget though, every time we take the derivative with respect to x of y, we need to do the chain rule and at the end have that dy dx. Alright, so your first term here is the x and your second is the y squared. So it's going to be x times the derivative of y squared would be 2y, then dy dx. So that was first times the derivative of the second plus the second with derivative times the derivative of the first. The derivative of x is simply 1. Okay, now what we're going to move forward and do is take the derivative of an implicit equation. So we said implicit equations are when we have x and y on the same side of the equal sign. All right, so these are the steps that we're going to go through in order to do this. First, it asks us to differentiate both sides of the equation with respect to x. So just like we were doing in the practice ones to begin, for the expressions, we're going to do that for both sides of the equation. Then we're going to gather all the dy dx terms to one side of the equal sign. We're going to factor out that dy dx, and we're going to solve for dy dx. Okay, so make sure, like as always, we're taking good notes and you're getting through and practicing all of these. Okay, so we're going to start off, and again, the instructions here tell us to find dy dx, and you can see we have an implicit equation because on both we have both variables on one side of the equal sign. All right, so we're going to go ahead and use our implicit differentiation rules. So we take the derivative of each of these terms with respect to x. So first, the derivative of x squared is 2x plus, when we take the derivative of y squared, we get 2y, and then dy dx equals, now the derivative of 25, well 25 is a constant, so the derivative of it is 0. Okay, so that was our first step. Our second step is to gather all of our dy dx terms to one side. So that means we want them only alone on one side. So in this case, that means we're pulling the 2y dy dx here, and we're moving the 2x to the other side, so negative 2x. Okay, the next step would be to factor out the dy dx. Here we only have a single monomial term, and so we don't need to factor it out, but what we do need to do is the third step, which is to solve for dy dx. So in order to solve for this, I would divide both sides by 2y, and so dy dx is equal to negative 2x divided by 2y. 2's obviously cancel, and so we get negative x over y. And that's our answer for that first one. Okay, our second problem here, again, we're going to go ahead and take the derivative with respect to x. So we would have 3y squared, and then your dy dx, plus 2y dy dx, minus 5 dy dx, minus 2x is equal to 0. Okay, so it looks like really all we have to do is move that 2x term over. Okay, so 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. Okay, our third step is to factor out. So you can see here we have a polynomial, okay, and each of these terms contains a dy dx. And so we're going to be able to go ahead and factor out the dy dx, and we're left with 3y squared plus 2y minus 5 equals 2x. Last step is to isolate the dy dx by dividing this whole thing over to the other side. So we would divide away 3y squared plus 2y, oops. So we're left with dy dx is equal to 2x over 3y squared plus 2y minus 5. Okay, as we approach this third one, we notice that we have, again, x's and y's on both sides of the equal sign. But on the right-hand side, we should notice that we have 6xy. And so again, we are looking here at the product rule. So here we have 6x times y. So as we go ahead and do the derivative of that right-hand side, we need to keep that in mind that we're going to have to use the product rule. All right, so let's start with the left-hand side. 3x squared plus 3y squared, and again, remember your dy dx, equals. Okay, so as we approach the right-hand side, here's the product rule. So 6x is your first term times the derivative of y. Okay, so the derivative of y would be 1, and then your dy dx. So you can just write dy dx. Okay, plus the second term is y times the derivative of 6x is 6. All right, so again, that was your first step. Second step is to collect all your dy dx terms to one side and your other stuff to the other side. So it doesn't matter which way you move it. You can do it either way. Okay, so I'm going to move the 6x dy dx to the right-hand side. I'm sorry, to the left-hand side, and all of my non-dy dx terms to the right-hand side. So I'll leave the 3y squared dy dx, and I will move over the 6x dy dx, equals, and now I have to move the 3x squared to the other side and join it with the 6y. So 6y minus 3x squared. All right, now I'm going to factor my dy dx out on the left-hand side. So that'd be 3y squared minus 6x equals the 6y minus 3x squared. Okay, and last step is to divide that away. So dy dx equals 6y minus 3x squared over 3y squared minus 6x. Okay, now hopefully as you're looking at that final answer, you notice you have a lot of 6's and 3's and x's and y's. So you want to make sure that there isn't a term or terms that you can divide out of everything. And so in fact, if we look here, you can go ahead and divide a 3 out of every single one of these terms. So we should go ahead and do that. Simplify that out. Now as far as the x's and y's are concerned, there is not a common variable in all 4 terms. So we cannot divide out an x or a y, but we can certainly take that 3 out. So as we do that, we'd have dy dx is equal to 2y minus x squared over y squared minus 2x. And that is our very final answer. Okay, as we approach this next one, again, we want to take a look at what we have. So we are given x squared, y squared, which we know again there is a product there, plus x sine y, again another product, is equal to 1. Okay, so as we approach take the derivative with respect to the first one, we're going to have x squared times, go ahead and take the derivative of y squared, which would be 2y dy dx, plus y squared times 2x. Okay, so that was the derivative of the x squared, y squared. Now, plus derivative of x sine y. So again, first times the derivative of sine y would be cos y dy dx. Because in this case, the y is your angle, and again, it's an angle something other than x, so I have to take the derivative of y, which is dy dx, plus sine of y times the derivative of x is just 1, equals the derivative of 1 on the other side of the equal sign is 0. Okay, so now, again, anything with a dy dx gets brought to one side and everything else to the other. So if I'm looking at this, I can see that this whole term has a dy dx and this whole term has a dy dx. Remember, terms are identified by everything's multiplying together. Okay, so those are the things I'm going to keep on the left-hand side. I'm going to move the other stuff to the other side. So I'm going to write this as 2x squared y dy dx plus x cos y dy dx equals, and now, like I said, the stuff gets moved to the other side. So I'd have negative 2xy squared minus sine y. All right, so next step would be, of course, to factor out your dy dx here. So dy dx, and then what's left is the 2x squared y plus x cos y equals negative 2xy squared minus sine y. Last step, of course, would be to divide that away. So negative 2xy squared minus sine of y over 2x squared y plus x cosine y. Now I just want to make an observation that we chose to move those terms, the dy dx terms, to the left-hand side and shove the other stuff to the right-hand side. If we had made the opposite choice, if I had moved these terms that I boxed in red to the right-hand side and kept these other terms on the left, well, what would happen is our negatives would be flip-flopped around. So I just want you to be aware that the chain effect of that would then give us an answer that would look like this. And I want you to be aware because, of course, this is an equivalent, exactly the same answer. And so I could have had 2xy squared plus sine y over negative 2x squared y minus x cos y. Because in essence, what I've done is multiplied my top and bottom of the fraction here by a negative 1. And so when I do that, it's multiplying by 1. Negative 1 over negative 1 would be multiplying by 1. And so in essence, giving you the same answer. Again, these are just multiple choice tips, because sometimes you'll get your answer and you'll be like, wait, it looks different. So take a breath and see, maybe they figured it out differently. Okay, last one of this type. Sine xy is equal to x plus y to the fourth. So this is a big one. We have chain rules on both sides of the equal sign. On the left-hand side, we have a chain rule because we are taking the sine of an angle other than just x. And that xy inside the that the angle is a product. So we're going to have to deal with the product rule as well. On the right-hand side, we have x plus y to the fourth. So again, a chain rule on that side as well. All right, so let's get going. On the left-hand side, okay, we take the derivative of the function, so that would be cosine, keep the angle, then times the derivative of the angle. So the derivative of this angle would be, first, derivative of y is dy dx, plus second is your y, derivative of x is just 1. Now notice that I enclose that in parentheses. That's going to become really important because my cos xy is multiplying times this whole binomial. So that is going to become important in a second. All right, equals. Now we take the derivative of the x plus y to the fourth. Again, chain rule. Bring the 4 down. Keep the inside, x plus y. Decrease the exponent by 1. Now times the derivative of the inside, which again you need to put in parentheses. The derivative of x is 1 plus the derivative of y is dy dx. Okay, so here's where that multiplication of this cos xy times this binomial and the 4x plus y cubed times this binomial is important. Because what we have to do here in order to isolate our dy dx terms is first we have to distribute these monomials into these binomials. Okay, so both of these places we have to do that. So in the left-hand side here, we're going to get, I'm going to go ahead and multiply cos xy times x dy dx. So I'm going to move the x in front. So x cosine xy dy dx plus y cosine xy equals. Now I'm going to do the same thing with the right-hand side. So 4x plus y cubed times 1 is just 4x plus y cubed. Plus 4x plus y cubed dy dx. Okay, so again, it helps me to kind of visually seek out all of the dy dx terms. So that would be this one over here. Oops, I lopped off the x, but it's all there. And this one over here. Okay, so those need to shift to one side and everything else to the other side. All right, so we're going to keep this x cos xy dy dx. Oops. And we're going to move over, so negative 4x plus y cubed dy dx equals. All right, now the other side we're shifting anything else that's left that wasn't boxed in to the right hand side. So I'm going to keep the 4x plus y cubed and I have to subtract away the y cos xy. Okay, factor out the dy dx over here. Very tedious, but I don't think any of this is extremely hard. It's just tedious and you have to work very slowly so you don't make mistakes. So x cos xy minus 4x plus y cubed is equal to this stuff over here. Okay, last step is to divide that away. So dy dx equals 4x plus y cubed minus y cosine xy all over x cos xy minus 4x plus y cubed. Believe it or not, that is our final answer, this whole big thing. Okay, this last problem that we're going to do is actually one of my favorite types of problems that we do. All right, so first of all, this notation. This is the first time that we've seen this notation, and it looks a little crazy. So what this is saying is find d2y over dx squared. What the heck does that mean? It really means find the second derivative of y with respect to x of x squared plus y squared equals 16. So we haven't done this yet. We haven't done anything other than the first derivative. Well, if you just kind of take a second and think about what do you think this second derivative is? Well, the second derivative is simply taking the derivative and then taking the derivative of the derivative, okay? And so that would be the second derivative. So we're going to go ahead and work through this, and as we do it, we're going to make, it's going to end up being this kind of cool puzzle. These always work out like this, and they're just really neat problems. All right, so here we go. We start off by taking the first derivative as we have in the past, okay? So when we take the derivative of x squared plus y squared equals 16, we get 2x plus 2y dy dx equals 0. Okay, I'm going to go ahead and solve for dy dx. So my first step here is to get dy dx before I worry about the second derivative. So I would do that by moving the 2x over and then going ahead and solving for dy dx would equal negative 2x over 2y, which this is very similar to the one that we started with, ends up with negative x over y. Okay, so now that we have the first derivative, now we're ready to begin the process of the second derivative. Okay, I'm going to work on the second derivative over here. All right, so if I took the derivative of dy dx, that would be my d2y over dx squared is equal to. Now the derivative of the right-hand side, well, that looks like the quotient rule to me. So low d high, well, the derivative of negative x is just negative 1, minus high, negative x, d low would be your dy dx, all over low squared, so y squared. All right, now let's go ahead and clean up that numerator for a second. So d2y over dx squared equals, so we have negative y plus x dy dx over y squared. Okay, now here's where this kind of gets fun. All right, you're going to go ahead, and if you notice here is you have this dy dx. Over here, we have dy dx, and we already found what dy dx equals. It equals negative x over y. So we're simply going to substitute what we already know dy dx is in for dy dx. So what does that look like? Well, we have d2y, the second derivative of y with respect to x, is equal to negative y plus x times negative x over y, all over y squared. Okay, so now we have this complex fraction, all right, where we have a fraction inside of a fraction. So how do I simplify that? Well, I go ahead and multiply both my numerator and my denominator by y. So by doing that, I'm going to get rid of that fraction in the top, all right? So what do I have? Well, this whole thing had to be multiplied by y. So I'm going to distribute it to both the terms in the numerator. So that would be negative y squared. And over here, that's going to cancel my y's out right here. And what's left is x times negative x, so minus x squared. Over y squared times y is y to the third. Okay. If you notice in the numerator, we have negative y squared minus x squared. I'm going to go ahead and just factor out that negative 1. And what I'm left with, oops, write the right variable here. what I'm left with is y squared plus x squared over y cubed. Okay, I have one more last step to do. Go back up to what we started with. We started with x squared plus y squared equaling 16. So here's another chance where we're going to take and substitute in for something we already know. Here is x squared plus y squared, obviously written in reverse order, but same exact thing. So x squared plus y squared equals 16, so I'm going to replace that x squared plus y squared with 16, and so my final answer here is negative 16 over y to the third. That is the second derivative of y with respect to x. So I love these problems because of this double substitution thing that always will happen. Okay, if you do them correctly, you will have a substitution in the first. When you do the second derivative, you're going to have a substitution for the first derivative. And then as you work through the problem, you will always end up with a place where you will substitute back in from the original problem, and so you will end up with a very small simplified answer. All right, that's it for tonight. Please make sure that you took detailed notes, and I will see you next class where we will practice a lot of these implicit differentiation.